Okay, I want you guys to title this geometric series. Okay? So what we're going to be talking about, we've already talked about what's called a geometric sequence. So I'm going to write geometric sequence and the formula that goes with the geometric sequence. You should already have this, right? But I'm going to write it anyways. A to the nth term will always equal the very first term times a common rate to the power of n minus 1. You should already have that in your journal right here. So that's a geometric sequence. Okay? So right here, the geometric sequence, if I said, what's this geometric sequence? And it's, we start with the 1/2, then we go to 1/4 and 1/8 and 1/16, comma, dot, 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 and goes all the way over here to 1 over 32,738. Right, 32,768. This right here, this is a sequence, okay? Right there. The geometric series, you'll notice, is the sequence. What are we doing to all of the numbers? We're adding all of the numbers together. So in a series, you're going to be adding all the numbers of the sequence together. Now, if we wanted to create a formula for this right here, I would say a to the nth term is the very first term, which is 1/2, times, what's our R value? What's the common rate? What's being multiplied to each one of these numbers? The R value is also a half, because a half times a half is a fourth, and 1/4 times a half is an eighth, and half of 1/8 is 1/16. So we put 1 over 2 power of n minus 1. That would be the geometric sequence that goes with these numbers. Now, you'll notice right here that they've given us a formula in sigma notation. So this formula right here will give us the sum of all of those numbers added together. All right, I want to show you guys how our little geometric sequence formula would work. Okay, so we're going to do the sequence formula, then we'll do the series formula. Okay, so here we go. Go to your calculator. All right, I want you guys to do 1 divided by 2, open parentheses, 1 divided by 2, close parentheses, to the power. And remember, if we plug it in, if we said n minus 1, what are we wanting to look for? We're looking for our 15th term. This is our first term right here. This is our first term. This is going to be our 15th term. So I want to plug in a 15. What is 15 minus 1? That's going to give us 14. So on my calculator, I'm actually going to do 14. I'm going to press enter. You're like, well, that doesn't make a whole lot of sense. Okay, I don't know if it'll change it to a fraction. It may or may not. Doesn't look like it's wanting to change it to a fraction. But if I said 1 divided by 32,768, we'll get the exact same decimal. Okay, 3.05 yada yada times 10 to the negative 5. Okay, so that's how you can check your answer. Now what we're going to do now is we're not going to find the terms. We're actually going to find the sum of all of them. So how do we find the sum? Using the sigma symbol. Okay, so here's what you need to do. In your calculator, hit alpha window, number 2. Here you're going to say x equals 1. Okay? Here we're going to add up the first 15 terms, and then we're going to hit alpha y equals enter, type in a 1, divide that by 2, and we're raising that to the power of x. That's how you would type it into your graphing calculator. Can we press enter? Yeah, interesting. So if you take a half, all right, and then you add a 4, and then you add an 8, and then you add a 16, what's going to happen over time? You're going to keep adding, right? As you keep adding those fractions, what number are you going to be getting really, 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 really close to? The number quite reaching. You're getting close to 1. Okay? So even if I did the same thing, I said, well, what would the first, not 15 terms, what would the first 100 terms get close to? What does the calculator do? It's going to round it up. So if I went up there and said, well, what about the first 1,000 terms? Oh, too much. You know what's going to get close to, but not quite equal? 1. It's going to keep going to 1. Okay? Because you're getting closer and closer and closer and closer to 1. All right, let's go back to our example. Right here. We're going to look at example number 2. All right. So this says an infinite geometric sequence. An infinite geometric means it's going towards the last number is infinity. It's like a concept. Okay. So what would all of this add up to? It's going to be going towards infinity. So let's kind of make it, let's go from infinite to finite. Let's just do the first 7 terms. Okay? So how about this? Let's just figure out what the 7th term will be. So this is A1. And I want to just stop it. I'm just going to do an example. I'm going to go to A7. And we're going to change it from infinite to finite. So here we go. I'm going to write my formula. A to the 7th equals the first term times our common rate. What does that seem to be multiplied by over and over and over again? 3. We put 3. All right. The power of 7 minus 1. Now what's our first term? Our first term happens to be a 2. So here would be our formula. A to the n equals 2 times 3 to the power of n minus 1. That would be the formula we would use. Now we're going to be plugging into 7. We're going to do 2 times 3 to the power of 6. 2 times 3 to the power of 6. 1,458. So what we're going to do differently using sigma notation. Okay? We're going to put a 7 here. We're going to put x equals 1. And then we're going to do, in parentheses, we're going to do 2 times 3 to the power of x minus 1. And we're going to let the calculator do this for us. What is it going to be doing? It's going to be doing 2 plus 6 plus 18 plus 54 all the way to our 7th term, which is 1,458. Remember, this is our first term. This is our second. There's our third. There's our fourth. We're going all the way to 7. Now, we'll go ahead and type this in. Back in the calculator. Hit alpha window, number 2. And hit x equals 1. Go over here, we're going to just do 7 terms. Our very first term was 2 times 3 to the power of x minus 1. All right? And we'll press enter. And what do we get? We get 2,186. So all of these terms added together is going to be 2,186. That's going to be what's called the sum of the geometric series. Okay? This is the formula right here that we would use to find the sum of the geometric series. Now, what would be our standard formula? Here we go. We're going to say x equals 1. This is going to be whatever the nth term is. I'll put nth term, whatever the nth term is. And this right here is going to be your very first term times your common rate of x minus 1. That's what you guys can put into your journal for for any particular formula. What are you always going to have to figure out? You're always going to have to figure out what the common rate is. What's that R value? What are you going to always figure out what the first term is? And how many terms are in that particular series. Whether it's 5, 50, 250, whatever it is, that's what you're going to have to plug in right there. All right, remember this right here. Okay, remember this right here. I'm going to go right down a little bit further to this formula right here. I want you guys to write Sn equals A1 parentheses 1 minus Rn close parentheses over 1 minus R. This right here is the same as what I just wrote down. I'm going to put n equals 1, a1 times r to the power of n minus 1, and this happens to be whatever the nth term is. This is how you write it in sigma notation. This is how you don't write it in sigma notation. Okay? So let's say you didn't have a sigma notation in the calculator. Let's say you couldn't do that. What can you do? You can still use this. And we're going to use the same example as we did. What was our final answer for this one? It was 2,168 when we plugged in all of that. When we plugged in that, our answer was 2,168. What was our first term? 2. What was our common rate? 3. What was our, how many terms did we do? 7. Over 1 minus our common factor of 3. We're going to plug this into our calculator, and what it's going to come out to is 2,168. Oh, yeah. I got things flipped. My bad. It's supposed to be 86, not 68. My apologies. Alright. So I'll go here. Make sure I correct. Oh, I had to write that time. 2,186. This time I got it flipped. Okay, so let's go ahead and put this in the calculator right now. We're going to hit alpha y equals enter. Alright, we start with a 2. We're going to do 1 minus 3 to the power of 7 because we're trying to do the 7th term. It's all 7 terms, and we're going to do 1 minus 3. We're going to press enter. Alright, I'm going to take a screenshot of this because I want you guys to understand that if you use this formula, you get 2,186. If you use this formula right here, you still get 2,186. And that means you're taking the first term and you're adding all the way to the 7th term. And that's how we got our answer. We're going to do a few example problems using some examples up here on the screen. So go and get ready for those. Here we go. Let's look at this word problem right here. Okay? It says Ethan wants to recreate the story of the rice and the chessboard, but he only has a column board which has 14 spaces. If he puts 1 grain of rice in the first space of the mountain column board, 2 on the second, 4 on the third. So we're going to make a little pattern here, okay? We're going to put A1, we're putting 1. A2 is 2. A3 is 4. Okay? And how far are we going to be going? All the way to 14, right? Is that what it says? 14? Yeah. 14 spaces. So we're going to use sigma notation. Okay, I'm going to say x equals 1. We're going to be doing 14 spaces, so I'm going to put 14 right here, so we have a total of 14 spaces. Our very first term, our A1 value is 1, and what's happening every single time? What's our R value, our common rate? Being multiplied by 2, right? Being multiplied by 2. Being doubled. And then we're going to put, over here, we're going to put x minus 1, just like that. So this is what I'd like you to do. I want you to write this down for this pattern. Okay, we're going to be adding all of those together all the way to the 14th space. Alright, so I'm going to hit alpha window, number 2. X equals a 1. Oh, so 14 there. 1 here. And we started at what number? We started at number 1. Multiplied by 2 to the power of x minus 1. $16,383. Alright, what was that again? 16,383. Alright, let's go and type that in. Okay. Do another problem here. It says Eduardo predicts his investment will have a return of 0.7 interest. Something you're going to want to write down on this particular problem. You're going to want to write down 0.7%, because we have to change this to a decimal. His initial investment is $250 on the first of the month. If he invests another $250 on the first day, on the first day of each month after that. According to his prediction, what would Eduardo's investment be worth at the end of the first day of the fourth month? Okay, so what we're going to do, is we are going to figure out what that percentage, what's the final answer going to be to the nearest 100. Okay. So here we go. Let's start with month number 1, second, third, and the fourth. So the first thing I'm going to do is just going to divide this right here by 100. So we're going to take 0.7 divided by 100. What's going to happen is that decimal place is going to move over to the left. So that decimal should be 0.007. Okay. Now what we're going to do is we're going to add that to, if you're earning 0.7%, you're adding that to whatever you already have in the bank, which is 100%, which is 100.7%. So this has a decimal. What we're going to be doing, our R value is going to be 1.007. That's our R value. Now, our very first term that we're starting with is going to be 250. Okay, so we're going to start with that. Now we're going to do this the long way. We're going to figure out if we can do a shortcut to this. Okay? So right here, we start with 250. Okay? And we're going to multiply that by 1.007. So what do you add now? $251.75. Okay? So right now, go back over here and put 251.75. So what's going to happen now? He's going to invest another what? $250. Right? And so that's going to get us to $501.75. So basically, on the last day of the month, right? He gets that. Then what does he do on the very first month? He adds another 250. So we're going to add 250. And then what are we going to multiply that by? 1.007. And now what's he up to? 505.26225. I'm going to write that down. 505.26225. He earns that at the last day of the month, and what's going to happen? He's going to add another 250 to this. Okay. I'm going to go back and add another 250 to that. I'm going to take that answer and multiply it by 1.007. $760.55. $760.55. $760.55. Now, if we did the fifth month, what would we do? We add another 250. But it says, what would it be worth at the end of the first day of the fourth month? Well, I guess we'd have to add another one. We invest another 250 on the first day of each month. There's the first, there's the second, there's the third. Looks like I gotta add another $250. So I gotta add another 250. So on the first day of the fourth month, his final total would be $1,010.55 if he had to add another 250. Our answer wasn't correct that we figured out right here. Here was our final answer. We take 250, then we add 0.7% to it each time. Basically, here's the pattern that you were following. You were doing it once, then you were doing it to the power of 2, then you're doing it to the power of 3. And so when you finally get the final answer, that got us all the way to this answer right here, which was incorrect.